All right, so if you have an array, two
Mhm.
ways of stepping through that, except I accidentally, wow. You can do this for like value in A, colon, print A. That's the for loop version, the for value loop. And then you can do a for range loop, but you need to know the length of the array to do that. So for I in range, for the length of the array, print the array element at subscript I, at index I. And so that one's a little bit more arcane. The syntax is a little bit more arcane. Well, what is that doing? It's doing this: print array element 0, print array element 1, print array element 2.
Oh, okay. 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 Now, when it says the print A with the I in the bracket, and
Right,
it printed all three, it's because you didn't tell it specifically.
right. We let the for loop count from 0, 1, and 2. Since the length of A
Uh-huh.
is 3, there's 3 items in the array.
Right.
So this for statement is going to count 0, 1, and 2. And so the I fills in 0, 1, and 2, just like it was printing out A to the 0, A to the 1, A to the
Okay.
2.
Okay. All right. Thank you.
Oh, sure
And then
thing.
the other one is this. Okay. I got you. Okay. I understand now.
Okay, cool deal.
Thank you.
One of the things I want to go do is, maybe I'll postpone that till Thursday. Let's go look. All right. So a new topic, although I don't know if it would serve us well to just go ahead and rehash some of the examples that we've already done. I think it might be a good idea, but the next thing we're going to talk about will be using parallel arrays. So what's parallel arrays? Parallel arrays are when you have 2 or more arrays of the same length talking about or describing. Like you could have an array of first names and then an array of last names and then an array of birth dates, right? And so all 3 of those would be the same length because everybody has a first name, everybody has a last name, and everyone has a birth date. So it looks like we're on lecture elemental PQ. So just as a recap, we'll do an array is a series of values of the same type. And the book likes to mention that they share the same name. I think I'm just going to leave that off. An array is a series of values of the same type. Python uses lists to handle arrays. The difference is that an array is fixed in length. Once you create it, you can't append to the end of it. You cannot grow or shrink. Whereas a list is dynamic in length, so it can grow or shrink. You can start it off as a size of 0 and then started adding things to it. And the guy who invented Python decided it didn't even need arrays because lists can do everything that arrays do. So Python does lists, not arrays, but everything that an array can do, a list can do better. So to define an array, you give it a name. And if you want it to be an empty array with no, let me think about how I'm going to phrase that. If you are going to initialize the array with data, it is really easy to do. So here's the syntax for initializing an array and filling it with data. So F names is equal to square quote Alice end quote Bobby end quote Carol. Right, like that. Here's how you initialize an array if you're not going to fill it with data. The syntax is pretty different. I'm going to call it, I don't know what I'm going to call it. I guess I'll just call it array 1 because I'm not feeling creative. Like that. That's saying we have an array of 20 zeros. So let's print out that, or let's print out F names just for funsies, and then let's print out the array. And we'll see that the first one looks exactly like we've initialized it up here. And then the next one's just going to be 20 zeros in a row. Just like that. Is there an advantage to doing one over the other? Well, this way just happens to already have the data in hand, right? If I wanted to go and fill these numbers in, if I wanted to do the last names in the most complicated way possible, because doing things in the most complicated way possible is silly, but why not? That's an L, not a 1, is equal to, and since we have 3 first names, I want to declare 3 last names. And so I'm going to do 3 times and then the squares, but inside of the squares, instead of a 0, I'm going to put 2 pairs of quotes like that. Let me print that out and let you see what it looks like. That is an array that's been allocated, but there's no data in it yet, right? It's full of emptiness. So we're going to put some data in it. So what's Alice's last name? L name subscript 0 is equal to her last name needs to begin with an A, and so we're going to call her Andrews. And then Bobby. L name 1, because that's the second element of the last array, because they start counting at 0. That's 0, 1, and 2. You know what? I never can think of names off the top of my head. What's a name that's last name that starts with B? Baggins, like Bilbo Baggins, the Hobbit. Alrighty. And then Carol. Carol is got the position of her name, 0, 1, and 2. So she's the element 2 in the list. Is Channing. So we have Alice Andrews, Bobby Baggins, and Carol Channing. Now, like I said, this is the most difficult way of doing that. I would not have done that under normal circumstances. I just wanted to demonstrate allocating an array and assigning the values. I was going to do the same thing with initializer list like this, which is what I would always do under, in an example where I wasn't deliberately trying to show something else. I would have done it like this. Oh, by the way, I've made a serious mistake here. Anybody spot the error? My variable is called L names.
Yeah, it is. Yeah.
Yeah. Let's fix that. All right. Now here's how I normally would have done it. Right. I just would have listed everything. Andrews, Baggins, Channing, like that, right? That would do the same thing as these 4 statements would. Hope that makes sense. I hope you see that this is a possibility, but it's just for demonstration purposes. I would have done it like this under any other circumstance. But I also hope that it makes sense what's going on here. This is like building an empty apartment complex with 3 rooms in it. And then we move a family or a person into the first apartment, the second apartment, and the third apartment, except just in weird computer land, we always start counting at 0 rather than 1. So apartment 0's got that name in it, apartment 1's got that name in it, apartment 2's got that name in it. So if you have an array of first names and an array of last names, and they correspond to each other with a one-to-one relationship, Alice Andrews, Bobby Baggins, Carol Channing, then that's a parallel array. I could do this. I could print F names subscript 0, comma, L names subscript 0, and do that again for 1 and 2. And so I'm going to copy and paste that. There we go. So what's it going to do? It's going to print Alice Andrews, going to print Bobby Baggins, and then it's going to print Carol Channing. Why are they called parallel arrays? Because they're the same length, and every element of them is tied by its position. That Alice Andrews, Bobby Baggins, and Carol Channing. So there we go. These are like columns in a spreadsheet in a way, right? If I popped open a spreadsheet, I could have a list of first names and then a list of last names. I wonder if yay. All right. So, you know, you could have F names and you could have L names. We had Alice Andrews and we had Bobby Baggins and we had Carol Channing. And this was subscript 0 and that was subscript 1 and that was subscript 2. So to print Alice, we needed to print F names subscript 0. To print Bobby's first name, we had to use F names subscript 1. And to print Carol, we had to use F names subscript 2. Same for the last names. So that's what's going on there. That's why these print statements print what they do. 2 parallel lists. We could list their favorite foods. So foods. I know it sounds weird to look like that, but anyways. So foods is equal to, and let's come up with a list of 3 foods that they like. Oh gosh, what starts with an A? I don't know. My brain freezes when I try to.
Applesauce.
Applesauce, yeah. And Bobby Baggins likes beans. And Carol Channing likes her candy corn. There we go. All right. And so again, parallel arrays. If we print out applesauce subscript 0, that will be Alice's favorite food. If we print out beans subscript 0, excuse me. If we print out, anyways, let's set up the example. Print. But let's do it with a for loop. Well, I mean, I guess we could do some cutting and pasting, but by the time you start doing a lot of cutting and pasting, you really should be using for loops. Take these 3 here. Now we're just going to use a for loop because I don't feel like making us copy and paste that much. So for I in range Now we need to count 0, 1, and 2. So we could just put a 3 there, right? But it's better to base it on the length of one of the arrays. And it doesn't really matter which one because they're all the same length. But I'm just going to go with first names. And so now I'm going to print F names, subscript I, comma, L names, subscript I, comma, quote, loves to eat, end quote, comma, foods, subscript I. And so when I is 0, it's going to print out Alice Andrews applesauce. When I becomes 1, it's going to print out Bobby Baggins loves to eat beans. And then when I becomes 2, because of the for loop, it's going to print, Carol Channing loves to eat candy corn. And there we go, right? So what is a parallel array? Parallel array are 2 or more arrays of the same length where the data elements are linked by their subscripts numbers or their index numbers. So every element in one array is associated with an element in the same position in the other array. Their example is going to be a list of item numbers and item prices. So here we have item numbers, 106, 108, 307, 405, 4 whatever, and then their prices. So item number 106 costs 0.59. Item number 108, which is index 1, subscript 1, costs 99 cents. Item number 2 is 307, and valid price is 2 is 450. So item number 2, so item 307 costs 450, and so on. So you use parallel arrays when 2 or more arrays contain related data, and the subscript relates the arrays. That's what I said in a different way. I said that the data elements are linked by their subscript number. Just like every row, on a spreadsheet has its own number. Alice Andrews likes her applesauce. He likes his beans. Candy corn. I'm going to hang with Carol. She likes the best food. So here we go. So if we wanted to get a hold of these 3 pieces of data, Carol Channing and candy corn, that would be F names, and this subscript 2, right? Subscript 2. Oh, hush. Yeah, whatever. Okay. And then if you had last names, subscript 2, and then you had foods, subscript 2, and I did not mean to put that C there. Anyways, when we try to print that out, it would print out Carol for that, F names, subscript 2. It would print out Channing for that one, last name, subscript 2, and it would print out candy corn for food, subscript 2. Let's do another example, kind of like theirs. book underscore ID equals, I'm gonna steal their idea of an inventory system. And the ISBN for that book is 111. The ISBN for that book is 222, and the ISBN for that book is 333. And then the book title, for some reason I've flipped from going from plural names to singular names. We'll just see about that. All right, and so our 3 books are gonna be, I don't know, old book about rabbits called Watership Down. And then there's another book about deer called Bambi, right? We've got an animal theme going on here. And a book about a dog is named Old, is it Yelled with a D? I think so. All righty, so there we go, right? We have 3 books, we have their ID numbers, and then we have their prices. So the book price is equal to, and let's list 3 prices separated by commas. Do you ever get on Amazon? I don't know if any of y'all actually use Kindle, but
Oh, yeah.
I download my books on Kindle, because I can read them on the laptop or on the iPad or whatever. And it infuriates me when they cost more than the physical books that are on paper, right? It's just electrons. You don't need to charge more than for the paper. Anyways, okay. Bambi's on sale and it's just $1.99, and Old Yeller is out of print, so it's really expensive and $13. So there we go, right? And then we could have book inventory numbers or quantity. So whoopsie, get back down here. Book underscore QTY for quantity is equal to, we have 12 Watership Down, we have 5 copies of Bambi, and we have just 1 rare copy of Old Yeller. There we go. So I think you can see what's going on. It's just like we're building a spreadsheet, right?
Yeah.
It's not tabbed out right, just like a spreadsheet would make it real pretty, right? I'm not, normally when I do these things, I'm not going to be adding a whole bunch of spaces just to make it look like that. But I could, when we printed it out, we could force each one to occupy the right number of columns on screen so that it would look really, really pretty when we printed it out. But for now, let's just print out this thing with a loop. It's going to be a range-based loop. You may be wondering why, if I love this other syntax so much that apparently I did that in the, remember this syntax for value in array print value? That's a lovely syntax, but unfortunately we need the subscript. This doesn't give us a subscript, it gives us values, right? So if I did for V in, first names, print V, it would print out Alice, Bobby, and Carol, but I wouldn't have that all-important subscript number to be able to also print out the last names and the foods or whatever. So this syntax is great, but it doesn't work with parallel arrays. So parallel arrays are processed using range-based loops because you need the subscript, because you need the index number. So this style doesn't work. Parallel loops. Instead, you have to do something like this. For I in range something, print, array element I, whatever, followed by as many other arrays, however many other columns in the spreadsheet you have, and so on. So that's what we're going to need to do here to print out our little inventory list here. We're going to need to use a range-based for loop for I in range. We need a length. All four of these arrays are the same length, so I can just pick one of them at random, book ID. And I want to print out all four things. Print. Book underscore, come on, ID, subscript 0 in subscript, book underscore title, not 0 though. We need that number to keep increasing each time, right? We need it to count from 0, 1, 2, and 3 so that we can 0, 1, and 2 anyways. Okay, there we go. So the book ID, the book title of that row, the book price of that row, and the book quantity of that row. Now it's going to print out our little book list. Ooh, index out of range. I have done something wrong. Oh, by the way, I have been using idle for, I don't know, 5, 6, 7 years. And if I knew this at one time, I had forgotten. When it refers to a line number, you can see those line numbers. All you have to do is go to Option, Show Line Numbers, and then boom, there they are. So it said there was an error on line number 64, and it said index was out of range. What is an index out of range error? Out of range is when you are trying to reference an element that doesn't exist. Like if I have some nums that look like this, 8675309, we know that there's only 7 numbers here. It's a phone number, 8675309. And we know that the indexes allowed are 0 through 6 because the length is 7, so we can go 0 through 6. That's element subscript 0, 1, 2, 3, 4, 5, 6. So if I print out, so sorry, gang, nums subscript 0, we're going to get the first element, right? The 8. And if I do num subscript 6, I'm going to get the 9, right? Because 0, 1, 2, 3, 4, 5, 6. And the length of that array is 7, right? 7 elements long, but 6 is the highest one I can get to because 0 to 6 is 7 elements. There's nothing after it. It's like trying to check into a hotel room that doesn't exist. If the hotel has 100 rooms, you can't get into room 101. So if I try to access anything past the end of that, like if I try to get into that one, it says the list index is out of range, just meaning that I tried to access an element that wasn't there.
So what was the problem then?
Well, I haven't figured it out. It printed out the first one.
Timothy's asking, you used I for the previous variable. Could that mess with it?
Let me look, and I'm sorry that I don't see the chat window. Let me flip over to find it. Yeah, let me look. Let me look at the code. No, it's okay to reuse a variable. So that shouldn't be a problem that I'm using I again where I'd used it before. But you're correct. Variable names, are, I always say variable names are meaningless, meaning that we could put anything we wanted into as our variable name there, right? As long as we were consistent.
Okay, you kind of lost me there from I, which means index, right?
Right. Ignore the fact that I made this, Fred. What I'm saying is that that variable name, it doesn't matter that it was used before, but I could change it. I could change it to X, or I could change it to the word index or anything. What it's complaining about is I need to print out I to find out which index number it's crashing on. That'll help me figure out the problem. And I didn't plan on this problem, so it's not like I'm, all right. So index 0, well, that's interesting. There should have just been one price and it printed out all the prices.
Well, there's only 1 0 on 13. Would that have mattered?
Yeah, let's go look. Oh,
Oh, well, there wasn't. There
there's a
isn't.
comma there.
Oh.
I've never accidentally done that before, but that broke the program. Delete that, it should work a lot better. All right, and now this word index is messing us up. I don't like seeing it. I mean, it's not a real problem. I could just stick index comma here, and then it's going to show that it's 0, 1, and 2.
I don't know why the word index and I is tripping me up, but it is.
Let me delete that. Let me actually just change that to I. Here we go. All right, and so there we go, right? It's printing it out.
Okay.
The I is just the number, the subscript, the index.
Of all of them.
Print out, right. And so the first book ID, the book ID at position 0 is 111. The book title at position 0 is Watership Down. The book price at position 0 is 599. And
that's what you showed in that other one. Was the I is such a simple little thing. It means it will print all the number. It goes back to that index and pulls it for all.
Exactly, right. And this is just a counter to count.
Okay.
0, 1, and 2.
Okay.
And I is not a magical thing. We could have called it subscript. Don't make these changes if you're typing along.
No, but does that have to be defined for you to do that?
It is. This defines it right there.
Okay. Okay.
Right.
Okay.
And then so that would work out just as well, except it's much wordier.
That makes better sense. Okay, now I'm getting it. Okay.
So I am going to undo that. There we go.
Okay.
So another thing we could do would be like months. We have several months. We have January. We have February. And we have March. You know, some years even have more months than that, but we'll just go with that. And we might want to calculate prices, or excuse me, sales for each month. In this case, we don't know in advance how many, we don't know the sales in advance. So I could either do this, and as a matter of fact, I might just do it this way, right? But I could have done that with that alternate syntax that I demonstrated way back earlier. What am I typing a word months here? Sales is equal to 3 times that. That would do the same thing. Tell you what, let's make this also go up to April. We're in April, we need to track all 4. So if we have 4 months, we need 4 sales. And I could have created that array by doing that. Those 2 statements would do the same thing. So let's ask the user for the sales for January, the sales for February, the sales for March, and the sales for April. We need another counter. Again, these are going to be parallel arrays. So January's sales are going to be that number. February's sales is going to be that number. March's is going to be that. April is going to be that. So for I in range len months, let's ask the question and get the answer. I'm just going to use the letter V because I'm not coming up with a better name for their answer. So the float version of the input of, oh, you know what? I better not do it like that. Tell you what, print, what were the sales for, end quote, comma, months, subscript I, in subscript in parentheses. And it's okay if these concepts are still kind of wobbly. Don't get frustrated because we're kind of doing stuff that's a little bit more difficult than we've done for the rest of the class. And so I don't mind spending the next 3 weeks talking about arrays if we gotta. This is important stuff and it's not that hard to get, but the first time you see it, it may stick in your brain, right? Just a slightly more. Well, anyways, we've asked them what were the sales for that month, and now let's get that input. I'm kind of wishing I hadn't used the variable name sales there because I sure would like to be able to use it here like that. But I guess I'll just go ahead and do it with the subscript counter, which is that. So the sales at that position is equal to the float version of the input like that. And so that's going to ask us each in turn, what were the sales for Jan? What were the sales for Feb? What were the sales for March? And what were the sales for April? So the sales for Jan were, $100, $200, $300. April's been kind of dim, so 10. There we go, right? And we could print out a loop that would display those sales if we wanted to. It'd be yet another for loop for I in range, parentheses, len, parentheses, months, close, colon, print the months at row I, at index I, at subscript I, and then the sales for that same row, that same index, that same subscript. And why am I calling them rows? It's just like that. If we call the first row 0, then the second row would be 1 and the third row would be 2. And so right now we have an array of months and an array of sales, and our row numbers are 0, 1, 2, and 3 because that's Jan, that's Feb, that's March, and that's April. And when we first created the array, we just filled it full of zeros, but our input statement, our input loop is going to fill them in. So when I is equal to 0 and asks what are the sales for January, and then we have an input statement, it's going to be filling in that value right there. And then when the loop reiterates, and so I gets increased by 1, it's going to say what were the sales for month 1, which is February. So it's going to say what are the sales for February. And then this input statement is going to store the result right there. And then I is going to increment to 2. And so when it says, what are the sales for months subscript 2, that's March. And when we type in our response, the user input gets stored into sales subscript 2. And then for the last time, when I iterates once more, and now I becomes 3, month subscript I, month subscript 3 is April. We let them type in the sales, and that gets stored into sales subscript 3, which is that spot.
I have a question.
Uh-huh.
Okay, so we got the 200, 300, 400 because of the placement in the index, right?
Well, I was just making numbers up.
Well, I don't understand how this calculated to 200, 300, 400. I see where it says 4 times, and then you have the 0 in there.
Those were numbers I was just typing in. I was purely making them
Oh,
up.
you're typing them in. Okay, I'm sorry.
Right. And so I should probably make this look a little bit better. I'm going to put a question mark there.
Uh-huh. Oh,
And
oh,
so when I run it in, or when I ran it, where did those numbers come from? They just came from the top of my head. You're,
oh,
you're
I
you're
didn't
right
know.
to wonder about that, right? So what were the sales for January?
Okay,
Well, I just checked my record books and I earned $877
okay.
of sales.
I didn't know you were typing them in. Okay,
Right.
okay.
And then what were the sales for February? Whatever. It was
I see.
a
Okay,
worse month.
thanks.
March was gangbusters.
Mhm.
April not over yet, so that was just 102, like that.
Okay, great.
So I'm hoping that the idea of parallel arrays is starting to gel
Hmm.
because you're seeing how they are lists, just like columns in a spreadsheet, first names and last names, last names, foods, book IDs, book titles, book. Sure is a ragged, sure is kind of jagged, isn't it? Let's see if we can make this look really pretty, but it's going to take some stuff that we haven't done before, which is some formatted print statements. Specifically, I want this one to look nice. So I'm going to go and copy that for loop and make it look more complicated in order to achieve the goal of it looking nice. And what do I mean nice? I want these numbers to be lined up in the right number of columns. I could just try using tabs. You know what? I don't want to botch this, so I am going to go and quickly Google Python format string. Yeah. All right. Okay. So where was that loop? That was this loop, this books loop. Now to make it pretty, we're going to copy the for loop, but I'm going to add a formatting string to it. The formatting string specifies things like how many decimal places a value would have. Like if you wanted it to be printed only to 2 decimal places or to 4 or to 8, you can specify that. And how many spaces on the screen that data should occupy. I don't think we need this. I don't know why I pasted that a second time. What happened? Did I accidentally delete something? Let me undo a couple of things. Oh, there it is. All right. So I don't feel like printing that I number anymore. That's just the index. It's not important to us. But I do need a formatting string. And this syntax looks a little bit weird, but here's what it looks like. It's got a string here, followed by a percent sign, followed by a parentheses. And it's okay if this doesn't totally sink in. We will do a few more examples of this. I just want to illustrate that we can make the output look prettier than we have been. And so in here needs to be a placeholder for each thing we want to print out, like the book ID, the book title, the book price, and the book quantity. And so it needs 4 placeholders that we're going to fill in. Now, what are the types of these placeholders? Well, these are numbers, but they are integers. And the placeholder for integer is just D. It stands for decimal, I think. These are strings, so its placeholder needs to be a %s. These are floats. So float F. And then lastly, the book quantities, those look like integers to me. So we're back to that. Okay, now when we run this, it's not going to look a dang bit different than what it did before, but that's because we haven't improved it yet. We specified some placeholders, right? But the only difference is that it printed the price out to 6 decimal places. That's not what we want. So what are we going to do now? We're going to specify the width for each one. I want the book ID to take up 5 spaces on the screen, or 10. I don't know how long ISBN numbers get. They can get pretty long. 10 ought to be enough. And the book title, book titles can get pretty long. So let's say that we want 20 spaces for the book title. And the book price, well, I don't know. Let's say that we don't have any books that cost more than $999.99. And how many spaces is that? That's 1, 2, 3, 4, 5, 6. So we need to put a 6 there. So it'll be 6 characters wide there. And then how about the last one, which was the quantity? Well, let's say that we never have more than 1,000, and 1,000 would require up to 4 spaces. So when I run it, it's going to look a little better. It's not going to look perfect because the prices still look kind of hinky, right? The decimals. I need to limit the number of decimals. And so I'm going to modify the placeholder for the price column, right? So this is the book ID column. This is the book title column. This is the book price column. I've said I want you to occupy 5 spaces on the screen, but I forgot to limit the number of decimal places. And so by doing .2, that says limit the prices just to 2 decimal places, because right now it's printing 6 decimal places for each one, which is silly. And there we go. Now we have our little book report here, right? A little inventory report. We could even print some kind of headers up here to try to make it look awesome, right? I could print, and I don't know how I'm going to pull this off. Right. This is the ISBN column. This is the title column. This is the price column. And this is the quantity column. There, right? And so now when I run it, this should actually look like a cute little report. All right, so we have a little table, a nice little report that we made from our data. Just because I consider it kind of important, and you may see this in the future, I want to explore these formatted print statements just a little bit more. It's not mandatory for you to start using them, but I want you to see them a little bit more. This stuff about asking for the sales each time, that's totally great, but it means that every time I run the program, I'm going to have to do input. So I think I'm going to scroll up and do this next little bit of stuff right up here at the very top. So if I do this, print, let's pick a number, whatever this number is, 1, 2.34, 5, 6, 7, 8. I could just print out F, or I could say, I want this to be 5 characters wide, 1, 2, 3, 4, 5, with 2 decimal places. So percent, meaning it's a placeholder, 5.2, end quote. And like I said, the syntax for this is gnarly. Sorry about that. Python language is really awesome, but this is one of the strangers index. And I want to print out F like that. And now when it prints it out, it's going to be only 2 decimal places. It's going to show 12.34. And I'm just going to stick an input statement temporarily here so that it doesn't do the rest of the program, right? That's just going to be kind of a pause. I'm going to delete this line eventually, but I just wanted to pause so that I can see the results of that. Ooh, incomplete format. Indeed it is, because when I added my percent signs down here, I needed to put a letter to indicate what kind of data it is. And this is a floating point value, so I need to put an F. The simplest version of it is just that, right? Print out percent %F, but then it's not going to be limited to two decimal places, right? So I'm going to add that stuff in and make it say percent %5.2, which means, or if I leave that number off, it doesn't specify a width, but it will still specify the number of decimal places. So this is going to have 2 decimal places. 12.35. What if we do 3 decimal places? It'll just be the same thing, like that. And that's just with one placeholder, right? We have one place value. Let's print something that needs several values. So like if we have F, let's print out F2 and F3, where each one of those is like 2 times F and 3 times F. So F is equal to 2 times F. F3 is equal to 3 times F. And we're going to print those numbers out. I'm going to, again, do the simplest version of it first and then make it more complicated, because if it starts off insanely complicated, it's almost impossible to see what's going on. We want to print out 3 numbers, F, F1, and F2. So percent F, percent F, percent F. I am regretting choosing F as my variable name because that F also shows up there. So I'm going to change this to something else. I'm going to change that to the letter X, right? Just to show that this F here does not mean the variable name, it's the type. Okay, so here we're printing out 3 numbers in a row. We're going to print out X, X2, and X3. So we have our 3 placeholders here. We put our our end quote there, followed by that all-important percent sign. I don't know why they chose that, but they did. And then the 3 variables we want to print are X, X2, and X3. All right, so there we go. But that's way too many decimal places. I don't want to see that many decimal places. So I'm going to say %.2F. Limit you to 2 decimal places. %.2F, %.2F. And there we go, right? So where will you see things like that? Well, like when you print prices, you don't want to see more than 2 digits after the decimal point on a price, right? We have dollars and cents, and we don't want to see 350 there or something like that. So what if you had some strange formula that calculated the price, and it said that the price of the item was, $2.99, but then the tax for that was equal to the price times, and this country has a really weird tax rate of 7.255, right? Really weird. And then the total is equal to the price plus the tax, and we wanted to print those 3 things out. We want to print the price. Well, we want to print the total. Total equals, end quote, comma, total. It's not going to look like a price. It's not going to look like, numbers that we want to see. We need to do some rounding. We need to fix our display somehow so that looks like legit stuff. So we're going to use that formatting technique again. So start off with the simplest case. There we go. It's a floating point price because it's got decimals, so we need an F there. The variable we are printing is called total. The message in front of it was the words total equals. Now this is not going to look great, but we're going to make it look better after the next iteration. So here it says, right, total is equal to 5.1. Wouldn't it be nice if we had a dollar sign in front? We can do that. All we have to do is add a dollar sign here. Dollar sign looking great, but how about this? It's got way too many things, too many places after the decimal point. So just like we did here to limit the number of decimal places after the decimal point to 2, we're going to do the same thing here. So dot 2F. All right, there we go. Total is equal to 5.16. Now, I haven't required us to format our data in any specific way, but this formatted stuff is how you get things to line up in columns, like we did later on in our example. Way down here, there we go, right? So we used our formatted statement, which is when you put some placeholders inside the strings and then you follow it by that %, and then in parentheses, you list all the elements that you're printing off, just like we did there. You can specify the widths, which helps you line things up in columns, and you can specify the number of decimal places. You can even get a little bit more complicated than that. And you could say whether you want those values to be left justified or right justified. Because these, if you know what left justified and right justified means, it means which margin is it, does it go against. And by default, these things are right justified, right? These are all going against the same margin. And these are all going against the same margin, right? And these are, maybe we wanted it so that, Bambi would line up right there underwater, not over here. And old should have started there. Well, we can fix that too if we so chose. And that makes this horrible example look even more complicated. Where did that go? Where are my books? Right there. If I want something to be left justified rather than right justified, I would stick a minus sign in front of the things that need to be right justified. Doesn't this look complicated? Well, if we learn it by bits and pieces, it'll start to make more sense. I kind of introduced the most complicated thing first. But if we break it down, %sign marks a placeholder. %d is for ints. %s is for string. %f is for floats. %10d means fill it to 10 spaces, pad it out with, to make sure it occupies 10 spaces. %minus 10d means fill it to 10 spaces and make left justified. So in other words, put the left stuff, put the spaces at the end. %10.2f means fill it to 10 spaces, restricting to 2 places after the decimal point. Except we didn't use 10.2, we used 6.2. How about this one, that 20s? %s is a string, right? Like the book title. %20s is a string padded to 20 spaces. And percent minus 20s, a minus sign means is the same, but left justified. All righty. We'll get back again to the topic of formatting. I wanted you to see it one time so that the next time I talk about it, it clicks a little bit more heavily. There is another way cool syntax for doing that kind of formatting. And I think I'm just going to stick to this syntax because you'll see this one in other languages as well. You can see this one in the C programming language and in the Java programming language and stuff like that. Oh, I can't help it. I have to demonstrate the other one. If we had a number called price, which we did right up at the top, then you could do this. You know how we've been doing this? Print price equals, in quote, comma, price. We could also do print, and here's where it looks weird. It starts with a little f, price equals, curly brace, price, end curly brace, in parentheses, that. And that would get filled in with the variable. So values is equal to the price followed by the tax followed by the total. And I need to move this up to where we were actually doing that, right? So I'm going to cut that line and move it way up here to the top above that input statement. And I'm not going to expand this example any more than that. But what I wanted us to see here, is it going to run or did I break something? Oh, here we go. Right, and so that variable here filled in that spot here, right? And that variable here filled that spot here. And that variable here filled that spot here. And we could do the same thing with limiting the number of placeholders. I mean, you know, limiting the number of decimals and stuff like that. And I'm really kind of fond of that because to me, this looks like maybe it would be easier for me to understand than throwing in 1,000,000% signs. But I just learned about this one. It's something that was introduced with Python 3. It wasn't about Python 2 or not. And this is a way that C and the Java programming languages and whatever since the 70s have been doing it. So it's got that kind of arcane syntax. All right, well, that was kind of a long aside. Are we okay with saying, yeah, we sure had fun formatting stuff, but we don't care anymore about it?
I do have a question
Sure.
about curly bracket things. Where you put price, tax, and total. So when you say the price, so the price in the curly brackets will refer back to the $2.99, and that's all you have to put, just the curly brackets.
Right, right. So if I had, you know, name equals Bob and career equals programmer, we could do print parentheses, and we have to put that little funny F there, which means a formatted string. And we could do name is a career.
Okay.
For company.
Okay.
And we don't have a company variable yet, but we will.
Yeah. That seems a lot easier than all the F's and percent.
Yeah, yeah. And I just learned that like 2 days ago. And so I'm kind of excited by it. I'm going to have to figure out a little bit more how to do that. But I
Yeah.
think that's pretty dang cool. So anyways,
Yeah.
next time we talk about formatted output, I'm going to veer away from using the percent signs, and I'm going to try to do it like that.
Good deal.
But to me, that's real intuitive, and I've never seen it in any other programming language. So again, Python's got a big, plus in its column for that. So I don't feel like making us have a homework over parallel arrays, at least not at this point, especially since the homework folder for the other one wasn't even there, so people may not have been working on it over the weekend. So let's wait till Thursday before we contemplate more homework. But I think we're done unless people have any questions over the material. I'm going to delete this input pause business. Or have questions about the last homework. How many of us are still here?
What's the benefit of using the curly brackets rather than what we've been doing?
Well, when you say what we've been doing, the way we've been printing before today.
Yeah.
Okay, very good question. How would I print this doing our current method? It would look something like this. Name, comma, quote, is a, quote, comma, career, comma, quote, for, end quote, comma, company. Now those will provide identical output. If you don't see an advantage of one way over the other, that's totally fine. If it got a little bit more complicated and we needed to do some formatting, like to, limit the number of decimal places or to make things line up in, in columns or stuff like that, then we would wind up using this syntax, except putting in the extra information required to format things to the correct width and not. And by the time we're doing that, then to accomplish that formatting, it's no longer as easy to doing this.
Okay.
So like if we had a salary here and Dubro's sitting pretty and he's earning $60,000 a year, let's figure out how that placeholder, no, I don't even know. But when we added a column for salary, if it needed to be formatted a little bit better, we may just come up with something that's easier to read than the syntax that would otherwise be required, especially if we were doing these placeholders like this and it started looking really nasty. That syntax for using the curly braces at least lets you put in names, right, of the variables as they are being printed out. So I would just say that the advantage of this is that if this is easier for you to read than this, then you might like it and go, ooh, that's cool. If it's not any easier to read, if it's harder to read, then this absolutely works.
It's mostly just down to preference.
It is, until we need to do some more complicated stuff, like I said, like for specifying number of decimal places or things like that, in which case you're going to have to commit to a more complicated syntax anyways. And I'm thinking that this one's going to turn out to be a nicer way of doing it than the way that I just showed it in the for loop.
Okay.
Seems a lot cleaner.
Well, it's clean right now because we haven't made it as complicated as this, right? We're not limiting the width and the stuff like that.
Right.
But even when it is, I'm hoping that it'll be, cleaner.
Yeah.
We'll hit that again on Thursday,
Okay.
and
Great.
it'll have gelled for a couple of days, and we'll be ready to eat it all up.
Are you going to put a Dropbox for the
Yeah, let's
home
do that. Let's do that.
and then for today's as well? Yeah. Okay.
There is a Dropbox for the homework now, and I'll put a
Okay.
Dropbox for today's
Okay, great.
lecture as well. I'm going to put this Dropbox in last week's folder and then move it to its own week afterwards. Temporarily, it's going to be in week 12, though.
Thanks for going over that again and again like that. It really helps.
Well, good. Oh, and the last one did not have its video link there. All righty. All right, there's a lecture queue Dropbox. It's in the week 12. I'll move it to week 13 after we're done.
Okay. We can just submit a notepad, right? I mean, it doesn't have to be an idle, right?
Oh, right. You can upload anything you want, even if it's just a comment saying, yo, awesome lecture, dude.
Okay.
Whatever.
Okay, it was too. Thank you.
All right. Okay, so I'll see y'all Thursday.
Okay, have a good one.
You too.
Thanks.
Bye.
Bye.
Bye-bye.